This is section 6.3, and we are going to solve this system of equations by using augmented matrices and Relish on form. So I have a -1, -2, 1, -1. Then I have 2 is next to x, so that goes there, and 3 is next to y, but there is no z. And then there's no x in this one. And so here's what our augmented matrix would look like. Just double check. I've discovered that the most common mistake usually comes from copying something down incorrectly. Okay, so we already have a 1 in the top corner. So I'm going to go ahead and just basically multiply this first row by a -1 to turn that into a +1. So all of my signs will change. Then I'm going to multiply row 1 by 2. And that will give me -2, which I will then add to the row 2. So 2 times -1 is -2, plus 2 is 0. 2 times -2 is -4, plus 3 is -1. 2 times 1 is 2, plus 0 is 2. And then 2 times -1 is -2, plus 2 is 0. Alright, so then we're going to just write down, I'm just going to go ahead and write down the bottom row as is. Figure out what I'm doing next. So next, I believe I need to multiply this row by a -1. So that will give me -1 times 0 is 0. -1 times 1 is 1. And -1 times 2 is -2. -1 times 0 is 0. Then for our bottom row, we want a 0 here. So I think I'm just going to look back at this step here, ignore the new row I just made, and ignore that -1 I just multiplied by, and just add these together. So -1 plus 1 is, well, 0 plus 0 is 0. And -1 plus 1 is 0, and 2 plus -2 is 0, and then 0 plus 0 is 0. So here's where we get our row of zeros. When that happens, our row of zeros means that there are infinite solutions. So this is a dependent system, which is infinite. So if you remember from section 6.2, we usually give the answer to things like this by using a parameter t. So instead of using x, y, or z, the way that we list our answer, we're going to say let z equal some real number t. So that's any real number t. Okay? So if z equals any real number t, then based on row 2, y minus 2 times t would equal 0. I've just replaced where we would have had a z with a t. So then y would equal 2t. Then I take my first row here and I would replace the y with 2t and the z with t. So I would have 1x plus 2y, so that would be 2 times 2t, minus 1 times t equals 1. So that gives me x plus 4t minus t equals 1. So that would be x equals 1. That would be a positive 3t. So subtract it to the other side, so negative 3t. So that's what my x value would represent. So as an ordered triple here for x, y, z, x would be 1 minus 3t, or negative 3t plus 1. Y would be 2t. And z would be t for any real number t. So when we say there's infinitely many solutions, it's true, there are infinitely many possibilities, but they are based on each other. So you can't just choose 3 random numbers and say, well, there's infinitely many solutions, so 1, 2, 3 is a solution. No, you would choose 3 for t, plug it in here and get 6, and then plug it in here and get -8 or something like that. So it's specific sets of 3 numbers that make it true, not any 3 numbers. T can be anything, and then everything else is based on that one number that's been chosen. Let's look at the next problem. So again, we're going to put this in augmented matrix form. 1, 1, 1, 4, 2, -1, -2, -1, 1, -2, -1, 1. Augment it. Alright, top corner is already a 1. So let's go ahead and multiply it by a -2. We're going to add it to that one. And then we'll multiply that row by a -1. And add it to that one. Okay, so those are the 2 things I'm going to do. So my middle row for now will be a 2, -1, nope, the negative, that row's not. Okay, so my top row is going to stay the same, 1, 1, 1, 4, right? So temporarily multiply the first row by a -2. So -2 times 1 is -2 plus 2 is 0. -2 times 1 is -2 plus -1 is -3. -2 times 1 is -2 plus -2 is -4. -2 times 4 is -8 plus -1 is -9. Okay, so that row's done. Now I'm going to do row 3. So I'm going to multiply row 1 by -1, add it to row 3. So -1 times 1 is -1 plus 1 is 0. And then -1 times 1 is -1 plus -2 is -3. And then -1 times -1 is -1 plus -1 is -2. Hope I did that right. And then -1 times 4 is -4 plus 1 is -3. Alright, so the next step would be to get a 1 in the middle, but I'm also going to be wanting to get a 0 here. So it might be easier if I just add these together. I wanted a different color. Add those together. So that will give me 0 plus 0 is 0. Oh, actually, I'm going to switch these to positive numbers really fast. So it's like I'm multiplying through by a -1. That doesn't change much. Okay, so then I wanted a different color. So I'm switching those to positives. 3 plus -3 is 0. 4 plus -2 is 2. 9 plus -3 is 6. I didn't quite draw that line in the right place. Okay, now to get my 1 here, I think I'm going to have to deal with a fraction. Sometimes that happens. So I'm going to go ahead and multiply by 1/3. So I would get 0, 1, 4/3, and then 3 here. Okay, so all I have left is to get the 1 here. I am supposed to be trying to get this to reduced though, so let's do that. So the 1 here is easy. All we have to do to get the 1 there is, I'm picking another color, multiply by 1/2, because then we get 0, 0, 1, and 3, which is awesome. Okay, let's find out what we've got. So we've got 1, 1, 1, 4, and we have 0, 1, 4/3, because I don't want to do a repeating decimal, 3, and now we're going to have 0, 0, 1, 3, because I multiplied everything by a 1/2. Great. Awesome. So there's reduced, that's row echelon form right there. So now to get it in reduced row echelon form, I'm going to multiply this row by a -4/3 temporarily. Don't panic. Then I'm going to add it to that row. Oops. Okay, so that leaves us with z equals 3. We already know that. That's good. And -4/3 times 0 plus 0 is 0. I'm just going to do that in red. -4/3 times 0 is 0 plus 1 is 1. -4/3 times 1 is -4/3 plus 4/3 is 0. Here's the tricky part. negative 4/3 times 3. It's not as bad as it seems because the 3's cancel and you just get a negative 4. You can add the negative 4 to the 3, which is a negative 1. Y equals negative 1. Our fraction went away. It was nothing to worry about. In case you didn't see what I did there. So this would be like multiplying by 3 over 1. So negative 4 times 3 is negative 12 divided by 3 is negative 4. Negative 4 plus 3 is negative 1. Alright, I'm going to go ahead and write my other line as is. Okay, so now to get zeros here and here, I'm going to multiply this by a negative 1 and add it to this row. Or I can multiply this by a negative 1 and add it to that row first. Which one did our pattern say was better? So looking at our previous pattern, so it says to find this one 7th, and then 8th, 9th. Do we already have our 0 there? Maybe not. Let's see. Yeah, we do already have that 0. Okay, so then 8th would be this one, and 9th would be that one. So I'm switching up. So I'm actually going to do this negative 1 times here, add to that to get that 0 here. Okay, so negative 1 times 0 is 0 plus 1 is 1. Negative 1 times 1 is negative 1 plus 1 is 0. Negative 1 times 0 is 0 plus 1 is 1. Negative 1 times negative 1 is 1 plus 4 is 5. Okay, so now we're going to multiply this one by negative 1 and add it to, so in this case we added it to that one, right? And this one we're going to multiply that by negative 1 and we're going to add it to that one. Okay, so that gives us negative 1 times 0 plus 1 is 1. Negative 1 times 0 is 0 plus 1 is 1. Negative 1 times 0 is 0 plus 0 is 0. Negative 1 times 1 is negative 1 plus 1 is 0. Negative 1 times 3 is negative 3 plus 5 is 2. And we have our answer. 2 for x, x equals 2, y equals negative 1, and z equals 3.